Hi folks, we're going to take a look at number 20 from page 147. So what they give us here is they give us a parabola y equals x minus 3 cubed. So, x minus 3 squared, so just drew that out. And they give us the point negative 3, 3. And they want to know what is the minimum distance from this point to that curve. Okay? So at some point here, there's going to be some minimum distance. Okay, so that's what we're trying to minimize here. Okay, so since we've got a point and we know that this is going to be joined to some point on that curve, we should be working with the distance formula. Okay, so we've got our point at negative 3, 3, and what we need is a point, a representative point on this curve. Okay, so if I call the x value x, well, I know that the y value is just the y value on that curve at that x value. So it's just going to be x minus 3 squared. Okay, so this keeps the variables we're using to a minimum. Okay, so let's apply the distance formula to these 2 points. So we know that it's the square root of x2 minus x1. So I'll start with this one here. So x2 minus x1. So x minus negative 3 is going to be x plus 3 squared plus y2 minus y1 squared. So it's going to be y2, which is x minus 3 squared, minus y1, which is 3, all squared. Okay? And here we have our distance given in terms of that one variable. Okay, so let's simplify this here so that we can then take the derivative and minimize it. Okay, so d is equal to, so here we've got x squared plus 6x plus 9. Okay, plus, and in brackets here we've got, so this is going to be x squared minus 6x plus 9 minus 3 squared. Okay, so d is, so looks like we're going to have some work to do here. X squared plus 6x plus 9. So here we're left with x squared minus 6x plus 6 all squared. Plus sign there. Okay, so on the side here, let me do that multiplication. So we've got x squared minus 6x plus 6 times x squared minus 6x plus 6. So let's multiply this out. So we've got x to the 4. Okay, here we've got minus 6x cubed plus 6x squared. Okay, so now let's do this one here. So we've got negative 6x times x squared, so minus 6x cubed. Okay, and here we've got plus 36x squared, and then negative 6x times 6 is minus 36x. Okay, and lastly, let's do this one here. So 6 times x squared. So notice here how I'm lining things up. 6x squared minus 36x plus 36. Okay. Sorry about that. Unfortunately, there's no pause button on this version of the software that I have. So here, what do we have? We have x to the 4th, so minus 12x cubed. So 36 plus 12 is plus 48x squared. Then negative 36 minus 36, negative 72x plus 36. Okay. So here, let's put this all in here. We have x squared plus 6x plus 9 plus x to the 4th minus 12x cubed plus 48x squared minus 72x plus 36. Okay, so d is equal to, so here we've got x to the 4th minus 12x cubed. Okay, now we've got x squared plus 48x squared, so plus 49x squared. So here we've got 6x minus 72x, so that is minus 66x sorry, 66x. I just want to make sure I don't make a mistake here. So yeah, minus 66x. Okay, 9 plus 36 is 45. Okay, let's take this crazy derivative here. So d prime is, so we know the whole drill, 1/2 times this to the negative 1/2. So we know in the denominator we'll have 2 times the square root of this thing. So in the numerator we're going to have to take this derivative. So 4x cubed minus 36x squared plus 2 times 49, 98x minus 66. Okay, so we need to determine when this is equal to 0, which of course is going to occur when the numerator is equal to 0. Okay, so so I could start trying to use the factor theorem here, and let's just check to see if there's some easy ones. So let's check, I guess, 1 and maybe 2. So here we've got 4 minus 36 plus 98 minus 66 is equal to 0, and there you go. It was worth a try. So x equals 1 is one of our factors. So here, let's do the division. So we've got 1, and here we've got 4, negative 36, 98, negative 66. So here we've got 4. So that's negative 32. So 98 minus 32 is 66, and of course we need this to be 0. Okay, so here we have x minus 1 times 4x squared minus 32x plus 66 equals 0. So here, so 66 is not divisible by 4, but it is divisible by 2. So 2 times x minus 1. So 2x squared minus 16x plus 33. Since that other division works, I'm actually curious to see if we can make this work factoring. So here 3 times 33. Sorry, I mean 3 times 11. 3 times 2 is 6. No, that's not going to work. So I'm not sure if this is factorable. So let's just, so obviously x can be equal to 1 or x can be equal to 16 plus or minus 16 squared minus 4 times 2 times 33 all over 2 times 2. So here we get 16 squared minus 4 times 2 times 33, which is negative. Okay, so negative in the square root means that that's not going to work. Okay, so the only thing we have to do is check to see if x equals 1 does indeed give us a minimum. So at x equals 1, let's test here. So let's put in 0 into the derivative. Okay, so in fact 0, so negative 66, so it is decreasing to the left of 1. And let's put x equals 2. So instead of, since I know the denominator is positive, I'm just going to put 2 into that. So here we have 2 minus 1 is positive. And let's put 2 into this thing. So 4 times 4 is 16. minus 32 times 2 is 64. So 16 minus 64 is something that's not as negative 66. So that's going to be positive. So here we indeed going from decreasing to increasing. So this is going to give a minimum value, and let's see what they're actually looking for. They're actually looking for the minimal distance, not the point at which it occurs. So the point at which it occurs would be when x is equal to 1. Okay, let's actually find the distance. So since it's x equals 1, that's pretty easy. Let's just put it into this equation. So distance is square root. Well, I'm going to want an exact answer, so I won't put in the square root unless it's a perfect square. So here we have 1 minus 12 plus 49 minus 66 plus, plus 45 equals 17. Okay, so the minimum distance is going to be root 17 units. Okay, so quite an interesting problem. Got to use a lot of interesting things here. Distance formula. And again, factor theorem, needed to be very careful.